Hello everyone and welcome back to our channel. In today's video, we're going to explore the maximum function in PySpark, an essential tool for finding the highest values in your dataset. Whether you're working with sales data, financial metrics, or other numerical fields, understanding the peak values can help you identify top performance, set benchmarks, and make informed decisions. We will go through various examples, including global maximum calculations and finding the maximum values within specific groups. So let's get started and learn how to make the most of the maximum function. Introduction to the max function. The maximum function in PySpark is used to calculate the highest value in a specific column of a data frame. It is similar to the maximum function in SQL and serves as an essential tool in data analysis for identifying the largest bin in your datasets. Whether you are analyzing sales, profits, or other numerical fields, finding the maximum value can provide insight into the best performance peak metrics or upper boundaries of your data. The maximum function can be applied directly to a column to find the highest value across all rows in the data frame. This is particularly useful when you want a quick overview of the largest value in your dataset, such as the highest sales amount, the maximum profit, or the latest date. By determining the maximum, you can understand the upper end of your data distribution, which can help set goals or benchmarks. Additionally, the maximum function can be used in combination with group by to determine the highest values for specific groups within the dataset. This approach helps you compare different categories or segments, such as finding the highest sales for each product category or determining the maximum salary in each department. By breaking down your data into groups, you can derive more granular insights and make more targeted decisions. Overall, the maximum function is an essential part of aggregation in PySpark, enabling to identify peak values in your data whether globally across the entire dataset or within specific groups. It helps you gain a clear understanding of the top performing areas, recognize patterns, and make informed decisions based on the highest metrics in your data. Basic syntax. The basic syntax for using the maximum function in PySpark is dataframe.group by calls.aggregate max column num. This allows you to calculate the highest value in a specific column, either across the entire dataset or for each group. The group by function groups data by one or more columns, allowing you to calculate metrics for each group individually. The calls parameter specifies the columns used for grouping. After grouping, the aggregate function applies maximum column name to calculate the highest value in each group. For example, grouping by category and calculating maximum sales helps you find the highest sales value for each product. Using group by maximum helps compare performance across different segments and identify the top metrics within each group, gain insights into the best performing area and upper bounds of your data. Why use maximum function? The maximum function is useful for determining the highest values in your dataset, such as maximum salary, price, or latest variety. It helps identify peak performance or upper boundaries, providing insights into the best metrics in your data. You can apply the maximum function to find the highest value across all records or use it with group by to calculate maximum values within different groups like regions or products. This helps you compare segments and identify the top performing categories. Overall, the maximum function is essential for understanding peak performance, recognizing the highest metrics, and making informed decisions. Practical examples: 1. Finding the maximum value in a single column. In this example, we are working with a PySpark data frame D that contains sales data for different items. The data frame has two columns, item and sales, where item represents the product name and sales represents the sales value for each item. Our goal is to determine the maximum sales value across the entire data set, which will give us insight into the highest sales transaction recorded. To achieve this, we use the aggregate function along with the maximum function. Specifically, maximum sales is used to calculate the largest value in the sales column across all rows in the data frame. This global maximum provides a quick summary of the best sales performance in the dataset, which is useful for understanding the peak sales amount achieved. We use alias max underscore sales to rename the resulting column as max underscore sales for better readability and clarity. This makes it easy to understand that the value represents the highest sales figure in the dataset. Finally, the dot show method is used to measure the result, which contains a single row with one column named max underscore sales that shows the maximum sales value recorded. For example, if the sales values are 100, 200, 300, 400, and 500, the maximum function will calculate the highest sales value as 500. This value provides insight into the upper boundary of sales performance, helping you identify the most successful transaction. This example demonstrates how to use aggregate along with maximum to calculate the highest value in a dataset. Finding the maximum sales value helps identify the peak performance and gives you a benchmark for the highest level achieved, which is useful for making informed decisions and setting targets. 2. Grouping and finding the maximum value. In this example, we have a PySpark data frame div that contains sales data for multiple items. The data frame has two columns, item and size, where item represents different product names and sales represents the corresponding sales values. Our goal is to calculate the maximum sales value for each item, allowing us to understand the highest sales recorded for each product. To achieve this, we start by using the group by function to group the data by the item column. This ensures that all records associated with the same item are grouped together. After grouping the data, we can then calculate the maximum sales value for each group, giving insights into the peak sales performance for each product. We use the aggregate function along with the maximum function to perform the aggregation. Specifically, maximum sales is used to calculate the highest sales value within each group of items. This helps identify the best performing sales figure for each individual product. By using alias max underscore sales, we rename the resulting column to max underscore sales to make it clear that the value represents the maximum sales for each item. And finally, the dot show method is used to display the result, which includes three columns, item and max underscore sales. The item column lists each unique product, and the max underscore sales column shows the highest recorded sales value for that product. For example, if item A has sales values of 100 and 300, the maximum sales for item would be 300. Similarly, the highest sales value for each item is displayed in the result. This example demonstrates how to use group by and aggregate with the maximum function to calculate the highest value for different groups within a data set. By calculating the maximum sales value for each item, you can gain insights into the best performance across different products, identify top sellers, and use this information to drive business strategies. 3. Finding the maximum value of multiple columns. In this example, we have PySpark data frame div underscore multi that contains information about different items, including their sales and profit values. The data frame has three columns, item, sales, and profit. The item column represents different products, while the sales and profit columns represent the corresponding sales and profit values for each product. Our goal is to determine the maximum value for both sales and profit across the entire dataset. To achieve this, we use the aggregate function along with the maximum function. Specifically, maximum sales calculates the highest value in the sales column, and maximum profit calculates the highest value in the profit column for the entire data frame. By doing this, we are able to identify the peak sales and profit figures recorded across all products, giving us a clear view of the highest levels achieved in both metrics. We use alias max underscore sales and alias max underscore profit to rename the resulting columns as max underscore sales and max underscore profit respectively, which helps make the output more understandable. The dot show method is used to display the result, which consists of a single row with two columns max underscore sales and max underscore profit. The max underscore sales column shows the highest sales value recorded in the dataset, while max underscore profit shows the highest profit. For example, if the sales values are 100, 200, 300, 400, and 500, the maximum function will determine that the highest sales value is 500. Similarly, if the profit values are 10, 20, 30, 40, and 50, the highest profit will be 50. This gives a summary of the peak performance for both sales and profit metrics across all products. This example demonstrates how to use aggregate along with maximum to calculate the highest value for multiple columns in a data frame. Finding the maximum values for both sales and profit helps identify the best performing metrics, providing insight into the highest recorded values and setting benchmarks for future comparison. This is especially useful for understanding the upper limits of your data and making informed decisions based on peak performance indicators. 4. Finding the maximum with a conditional expression. In this example, we are working with a PySpark DataFrame DF that contains sales data for different items. The data frame consists of two columns items, high list where item represents the product name and sales represents the sales value for each transaction. Our goal is to find the maximum sales value, but only for the records where the sales value is greater than 200. This helps us focus on higher value transactions and ignore the smaller sales figures. To achieve this, we use the when function in combination with the maximum function. The when function creates a conditional expression that filters the rows based on the given condition. In this case, when df.sale is 200, df.sales checks if the sales value is greater than 200. If the condition is true, it returns the sales value, otherwise it returns null. This ensures that only the sales values greater than 200 are included in the calculation of the maximum value. After creating this filter selection, we use the aggregate function along with maximum to determine the highest sales value from the filtered rows. Specifically, maximum when the f.sales greater than 200, the f.sales calculates the maximum sales value for transactions where the sales are greater than 200. By focusing on sales above 200, we can gain insight into the peak sales performance for higher value transactions. To make the result more readable, we use alias max underscore sales underscore over underscore 200 to rename the output column as max underscore sales underscore over underscore 200. This makes it clear that the value represents the maximum sales value for transactions above 200. Finally, the dot show method is used to display the result, which consists of a single row with one column named max underscore sales underscore over underscore 200, showing the maximum sales value from the filtered data. For instance, if the sales values are 100, 200, 300, 400, and 500, the maximum function will calculate the highest sales value among 300, 400, and 500, resulting in a value of 500. This selective aggregation helps to analyze the top performance among higher sales values, which can be useful for understanding significant contributions, setting performance benchmark. This example illustrates how to use conditional logic with when in combination with aggregate and maximum to perform selective aggregation. It is especially helpful focusing on specific segments of your data to better understand peak performance with a defined range, aiding in targeted analysis and decision making. 5. Grouping and finding multiple maximum values. In this example, we have a PySpark data frame diff underscore multi that contains information about different items, including their sales and profit values. The data frame has three columns: item, sales, and profit. The item column represents the product name, while the sales and profit columns contain the respective sales and profit values for each product. Our goal is to determine the maximum sales and profit for each item, allowing us to understand the peak performance of each product. To achieve this, we start by using the group by function to group the data by the item column. This step organizes the data into groups where each group represents a distinct product. After grouping, we can perform aggregation operations on each group independently, enabling us to analyze metrics at a product level. Next, we use the aggregate function with the maximum function to calculate the highest values for both sales and profit within each group. Specifically, maximum sales calculates the highest sales value for each item, while maximum profit calculates the highest profit value. These calculations give insights into the best performing metrics for each product in terms of sales and profit. We use alias max underscore sales and alias max underscore profit to rename the resulting columns to max underscore sales and max underscore profit respectively. This makes the output more descriptive and easy to interpret, clearly indicating that the values represent the maximum sales and profit for each item. Finally, we use the dot show method to display the results, which consists of three columns: item max underscore sales and max underscore profit. Each row shows a unique item along with its corresponding maximum sales and profit values. For example, if item A has sales values of 100 and 300 and profit values of 10 and 30, the maximum sales for item A would be 300 and the maximum profit would be 30. Similarly, the results for other items will show their highest recorded values for sales and profit. This example demonstrates how to use group by and aggregate with the maximum function to calculate the peak performance metrics for different groups in a dataset. By determining the maximum sales and profit for each item, you gain insights into the highest performance achieved by each product, helping you understand which items are performing best and make informed business decisions. 6. Finding the global maximum value. In this example, we are working with a PySpark data frame diff that contains sales data for different items. Data frame consists of two columns, item and size, where item represents the product name and sales represents a value for each sales value plus transaction. Our goal is to determine the maximum sales value across the entire dataset without grouping by any specific item. This allows us to identify the highest sales transaction overall, providing a summary of peak performance in the dataset. To achieve this, we use the aggregate function along with the maximum function. Specifically, maximum sales is applied to calculate the largest value in the sales column for all rows in the data frame. This global aggregation provides insight into the highest sales figure recorded across the entire dataset, which can be useful for setting benchmarks or understanding the top level performance of the data. We use alias global underscore max underscore sales to rename the resulting column as global underscore max underscore sales to make the output clear and easy to understand. This alias indicates that the value represents the highest sales value globally across the entire dataset. Finally, the dot show method is used to display the result, which consists of a single row with on column named global underscore max underscore sales, showing the maximum sales value recorded in the dataset. For example, if the sales values are 100, 200, 300, 400, and 500, the maximum function will determine that the highest sales value is 500. This result gives an overview of the highest sales performance, helping you understand the peak point in the dataset. This example illustrates how to use aggregate along with maximum to calculate the maximum value across the entire data frame. The global maximum provides a useful summary of peak performance, allowing you to understand the upper limit of data and use this information to make informed business decisions, set goals, or benchmark against other datasets. Thanks for sticking with us until the end of this video. I hope you now have a solid understanding of how to use the maximum function in PySpark to identify the highest values in your data. Whether you need to find the global maximum or calculate it within different groups, this function is a powerful tool to help you analyze data more effectively. If you found this video helpful, please give it a thumbs up, share it with your friends, and subscribe to our channel for more data analysis content. Also, feel free to drop your questions or comments below. I'd love to hear your thoughts and help you out. Until next time, keep exploring and happy coding.